My name is David King and I'm a radiologist. So I'm a doctor at York Hospital, and my job involves using X-rays and different sorts of scans to diagnose bone and joint injuries and other diseases of the bones and joints, among other things. For this exhibition we used a CT scanner to get pictures of some of the bones of the people. And to understand how a CT scanner works, it's useful just to understand how an X-ray is taken first. So with an X-ray, originally a photographic film was put behind the part of the patient being X-rayed. These days we would use an electronic digital detector, and the X-rays are shone through that part of the body, and that will blacken the film or be detected by the detector plate. And the more dense tissues, like the bones, come out as whiter on the picture, and the less dense things like hair are blacker. So there's a grey picture formed. A CT scanner also uses X-rays to create the picture, but this time the detector, instead of just being fired once from the front, rotates in a circle around the area being scanned, and also the area being scanned will move through the scanner at the same time. So what you end up with is a whole volume of information about the densities of the tissues. And then using a powerful computer you can reconstruct that to show slices through that bone or that part of the body, or you can use the data to make a 3D picture. And we've used a combination of both of those for this exhibition. One of the people that we scanned part of their pelvis. It was in several fragments, but we taped those together in the way they would have been during life, and acquired a 3D picture of that. And you can watch that bone rotating. So in perhaps the display you can just look at it from certain angles. Here you'll be able to see all of it from every aspect as it turns around. And the other thing that we were able to do with that pelvis is where it's there's thought to be a bite mark, we can do a slice through the bone there, and we can look at the depth and the shape of that mark in the bone. So in other words, we can see into the inside of that bone. So this is part of the pelvis in the person who's thought to have been bitten by a large animal, and there's a mark in the bone which you'll be able to see in the display. And this is a slice taken through the pelvis, or part of the bone of the pelvis, along the line of where that bite mark is. So we can see the shape of the mark here, and this is felt to correspond to the shape of a carnivore tooth, and we can see how deep it is. And you have to remember that the pelvis, like yours and mine, is covered by quite a lot of flesh, so for the teeth to have actually bitten through into the bone, it would have had to go through the skin and the overlying flesh, and then got stopped when they reached the bone here. Another person who we scanned their skull and their cervical spine, in other words the bones in the neck here, and we reconstructed those pictures taking slices, for example in this plane like this, and that enables you to see perhaps a bit more clearly how one of the bones at the top of the spine there has been cut through with a blade, and you can see how the bone is split across at the time of that happening. So this is the person whose head and neck we scanned. We had to put the bones where they would normally be in relationship to one another because the person had been decapitated. So we scanned the whole of the head and the top of the cervical spine, which are here. These are the bones in the upper part of the neck. And then we reconstructed to get a picture that was a slice straight down the middle through the nose and through the middle of the neck, like that. And so that's what this picture is. And this is the skull at the front and the nose here and part of the upper jaw with a tooth. and this is the top of the neck bones here. And this black line across here shouldn't normally be there, and when this person was decapitated, this is where the blade sliced through this bone here. And I can show you another picture of that. And this time we've reconstructed in this direction, so it's like a slice coming down like this through just one of the bones at the very top of the neck. It's the second one down, in fact, and here we've got this cut across the bone, so a very strong blow with a blade has cut straight through the bone and cut the head off this person. So, and the third area that we scanned were the tibia and fibula of the two legs of one of these people. On one of the sides, it's clear that the bone is thickened at the front of the tibia, and that indicates that sometime when the person was alive, there was a fracture of that bone, and during the healing process, the bone became thickened there, and has then mainly remodeled back into the normal shape, but not completely. So that's a typical appearance of a previous fracture on the CT scan. And because of the two-dimensional slice across the bone, you can appreciate the detail of that injury a lot more clearly. This is one of the pictures from the person who was wearing leg irons. It's a cross-sectional picture through the tibias, which are these bones here, and the fibulas, which are the smaller bones in the leg below the knee. This leg is normal here, and this is the thickness of the outer part of the bone and the normal structure inside the bone of the tibia. Whereas on this side you can see there's a lot of thickening of the bone around this part of the tibia, and this is where the person's had an injury when they were alive, and the bone has healed around the site of the injury to create that thickened appearance here.